Welcome back to another episode of the CSK8 podcast. My name is Jared O'Leary. In this week's episode, I'm interviewing Shuchi Grover. In this episode, we discuss the importance of having a variety of assessments in a computer science class, why we need more research on computational thinking, why educators and scholars should read literature outside of the field, and what people can learn by reading Shuchi's new book titled Computer Science in K-12, an A-To-Z Handbook on Teaching Programming. As always, the show notes include some extra resources related to this episode. For example, some of the papers that Shuchi recommends reading. So you can access those show notes by visiting jaredoleary.com or by simply clicking the link inside the show notes for the app that you're listening to this on. I hope you enjoy this wonderful interview with Shuchi, which will now begin with an introduction.
So I identify primarily as a researcher, a learning sciences and computer science education researcher. I have occasionally taught in a classroom, but it's mostly been as part of research projects. I've actually taught more teachers maybe than students directly as part of teacher PD, and that I have been doing for a long time, even before I came into CS education, working with teachers as part of technology integration and such. I've actually also taught a class at Stanford on how to teach introductory CS and programming. And that course was aimed primarily at TAs of undergrad courses and students from the ed school at Stanford. My journey into CS ed research, I guess, was not very straightforward. I started my professional life as a software engineer. I had a bachelor's and master's in computer science. My bachelor's was in India, but then I came to the US for my master's. After some years of doing that and an entrepreneurial venture during those dot-com years in the 90s, I decided to go into education. And so I sort of moved from CS into education. Sort of when I think back on why that might have happened, I think it may have had to do with my master's thesis at Case Western in 1992. Which is pretty interesting. The object-oriented programming languages had just come out.
Mm-hmm.
The CD-ROM had just come out for those of you youngsters that are listening. So we were creating applications in this language called Smalltalk for students of music. And this I want to mention because of your background. Students of music and art, because there was a lot of digitization going on in libraries at that time, and of music and art. And this was called the Library Collection Services Project as it happened. And they had partnered with IBM and the computer science department at Case Western. And we were creating these applications that would be used by students, in classrooms for students of music. So one app, for example, was where the music would play on the CD-ROM. I remember we were working with the Brandenburg concertos and stuff like that. And there would be a score sheet on the screen and there would be a moving highlight to show what score was playing, at that time. And so that was like a pretty cool project for that time. And it was a huge thrill to see CS being applied in the context of education.
Yeah.
And then around 2000, I decided to go into education and did a master's at Harvard in the Technology, Innovation, and Education program. And I think that was what set me on this path of children and coding, was this volunteer work that I did at MIT Media Lab. Mitch Resnick and Natalie Rusk at the Media Lab and others had a grant with museums around the country called the Playful Invention and Exploration Network with museums. And the children were engaging in tangible and physical computing with the Media Lab Cricket, which was basically the microprocessor that went on to be the brain in the Lego Mindstorms kits. And so the idea was to basically have students use the cricket to actually create fun things along with craft materials. Even back then, I think there was this belief that the early Mindstorms was already out by then, was very robotic. It was robotic, but it was very male-centric with the wheels. And I mean, you can only think of building cars or moving things like that, roving things, but you couldn't think of pretty flowers or bugs and things like that. So I had volunteered for those workshops, and that sort of, stayed with me. I went on to work informally in schools with children in after school settings, actually. And I was an ed tech consultant for teachers and working with teachers in classrooms. But with students, I had these after school robotics and digital storytelling clubs that I had created. And these were all centered around children learning to program. And that's when I started experimenting with the pedagogy of teaching programming to kids. Because of my background in CS, I would see those sessions as ways to teach some of these ideas that we now call computational thinking, I used to write blog posts at that time, and once in a while an article for ISTE and whatnot. And I would talk about these very ideas that we now see as computational thinking. So I had started to engage with this idea quite passionately. And so that's how then I came into my PhD, and the research topic was, I guess, a very organic journey from my work as a practitioner, and then wanting to understand how we can enrich students robotics and other programming experiences by also teaching some foundational ideas of computing and computational thinking. And so, my PhD dissertation was in the learning sciences, but it was situated in the context of computer science education for middle school. I designed a curriculum. It was a great learning experience because I looked at this topic from so many sides, whether it was curriculum design, pedagogy, assessment, perceptions, motivation, all of that sort of became part of that experience. Since then, I've been involved in several NSF projects and other grant funding bodies as well that look at pedagogies for teaching CS, computational thinking, curriculum design, assessment, integration of STEM and computing. But my principal affiliation is with a small R&D venture in the Bay Area in California. It's an NSF-funded R&D venture. I'm a principal research scientist there. It's called Looking Glass Ventures, and I'm also visiting scholar still at Stanford. So that's a long-winded introduction.
Yeah, I really liked your point about your dissertation in particular. Far too often, I see a lot of researchers, they have this like microscope view of education. And so they hone in so closely on one particular thing that they ignore or forget everything else that goes into education. So I think it's important to kind of zoom out and think of so many different factors that go into kids' learning. Can you tell me a story about an experience either in education or in your research that continues to impact you today?
So, this was a piece of my research during my dissertation. It was around the idea of helping students build perceptions of computing. Basically, it had to do with opening students' eyes to what computer science is, to what computing could mean. There was this research on expansive framing, which someone called Randy Engel at Berkeley was doing, and she had just passed away around that time. And, it was a huge loss to the learning sciences community because she was looking at transfer and how, when you look at a social view of transfer rather than a cognitive view, the idea was that if you help students see broader connections to what they're learning beyond the classroom and a future use of that learning, then the brain is somehow primed to actually learn better, and you transfer better. You sort of learn those ideas better. And so the whole idea was to expansively frame this curriculum by giving students a broader sense of what computing means, by making real world connections. So I brought in this idea of using videos from YouTube, and also speaks to identity. So I was thinking at that time, and I'll be honest, at that time I was thinking gender for the most part. Let me have videos that show girls and different industries, craft, music, healthcare, and also, sort of a mix showing a lot of different ideas. But I also actually recorded vignettes of computing with people around me. There was a Muslim girl who used to wear a hijab at Stanford. I interviewed her, a black cohort mate who was doing these interesting things with computing. So I did think of representation a lot at the time because of this idea of helping students sort of see their future selves. And it also sort of was a proxy for sort of bringing role models into the classroom. So it sort of played a lot of different roles. I feel like we need to consciously make the real world connections much better. We need to attend to issues within the curriculum itself and not sort of separate from it. So ideas that they're learning in the classroom about simulations, about something, we could do so many things to sort of make the connections, but also tie it to identity and this idea of expansive framing. So that is one idea that has impact, and I feel that it has a huge role to play when we talk right now about social justice and culturally relevant pedagogy. I think we need to be showing examples of all kinds of work done by all kinds of people around us, not just, the popular examples of Mark Zuckerberg and Facebook and things like that.
So, what's something that has surprised you over the years with your research on computer science and computational thinking?
During my dissertation in middle school classrooms in the Bay Area, I had designed all kinds of assessments, formative assessment quizzes, open ended and closed ended programming projects, multiple choice quizzes for formative learning, Parsons problems in Scratch. I think I might have been the first one to try those out, mixing up Scratch blocks on the stage and giving to students, reflective notes on their final projects. I even did artifact based interviews at that time. I had a couple of students in my second iteration of the study, students in class who the teacher had sort of labeled as problem kids, to me. And she had said, they are, students who are behind in several subjects and they have learning difficulties and they've just been put into this elective classroom because there's nowhere else to place them, was the way she had said, that they hadn't elected to be here, they'd been placed here. They happened to be students of color and they were often not on task. They were off task a lot of the times and they didn't do so great. They were behind in their submissions of the projects that kids had to complete. They didn't do so great in the quizzes. And in the pre-post, one of the great things about my research was every student showed pre to post gains, but these students sort of did poorly in the post test, even though they did better than the pre-test. When it came to the final open-ended project, these two kids were partnered with each other. And I was a bit apprehensive. I felt maybe they should partner with somebody else. They might learn. They will sort of learn through working with someone else who's sort of done better in the class, so to speak. And, my interviews with both these students really blew my mind. And it really changed my view on assessment. Not only were their final projects pretty good, it extended the maze project that we'd already done in class, but in such interesting ways. And they created levels and they created this scary scream at the end because it was Halloween and they had just watched this movie, they told me in the interview. And the interviews were conducted individually with each student. And they showed me the bug that they had and the fact that they couldn't fix it. And through talking with me, they actually figured out, each of them individually managed to figure out what the bug was. And actually, they were explaining concepts to me, that I had taught them in ways that I could not see through the pre to post assessment, right? In the pre post test. And so this really brought home to me the idea that certain assessments privilege some children more than others. And there are many things that you can learn from quizzes and get quick feedback, but you also have to sort of give students opportunities and ways to show their learning that they can do better, privilege their own voice a little more and their learning and show it in ways that, may not come through in other forms of assessment. So this idea that, you, in order to get a holistic view of a child's learning, you have to sort of have this wide variety. And the formative assessments and quizzes also played a part. For example, I think I've even written a paper about this, about how the dashboard on the day of the day I introduced variables, I mean, suddenly the formative quizzes performance plummeted for the aggregate. Very few students did well on certain problems, and those, I realized, those problems revealed misconceptions. I went back and sort of repeated some, tried to change how I was teaching something. So for, the role of formative assessment quizzes that give you quick feedback on things kids may not have learned is valuable, but reflections are valuable. You've talked about ipsative assessments, those are valuable. Artifact based interviews are valuable, and so are open-ended projects. But we have to sort of understand what role each plays and how you can incorporate. You can't just give projects because it's very hard to grade, it's time consuming. Students take time to do them and you take time to grade them, and so when are they getting that feedback? I even saw that kids did things in groups where, sometimes one kid couldn't explain what a certain part of the code was doing because my friend did that. I don't know it. So it also reveals that the presence of a construct or a presence of certain parts of the code may not indicate understanding.
So one of the problems that I have with like automated assessment stuff and like only using that is sometimes you have happy accidents in code where it's like, oh, this works. I don't know why it works, but it works and cool. So when it gets like automatically graded, it's like, oh, they understand conditionals or variables. And it's like, well, maybe not. So I like the multi-perspectival approach that you're recommending. And for people who aren't familiar with it, so the formative stuff, like in the process, assessment and kind of understanding, then the summative is typically towards the end, sometimes with a pretest. And then ipsative is more of like a reflection on what do you know now? What did you learn through this project? How does that compare to your prior understandings? So, like those, like different approaches to assessment, I totally agree with. What would you recommend for educators in terms of when either selecting or designing their own assessment that they would use with the kids they're working with?
I feel for the way that we are proceeding in CS, I think the summative assessment is, of course, great, but it's great for reflection on the curriculum, reflection on what might change from cohort to cohort, because it happens too late in the process for you to for it to impact learning for that cohort of students. So it's great as a reflective tool, but for your ongoing teaching and your ongoing district curriculum and teacher PD, etc. And you see things in the aggregate in the summative assessment for the most part. You sort of see, oh, most students, were able to get a handle on this kind of topic or concept, but not so much on this. So how might I teach this better? For formative assessment, I think that is it's a mindset. You have to sort of constantly tell yourself, I need feedback from students on what they are learning. And this can be done in so many different ways. It can be informal questions as you're having a whole class discussion. It can be their expressions as when you ask something and
Yeah.
blank faces. But I think most teachers, this is not something new to teachers. Teachers have been doing this all the time. So formative assessment can be more informal, like I said, the expressions, what students are responding, what to when you ask them a question as they're coding and whatnot. And it can be a little more formal too, in the form of exit tickets on a daily basis or every other day, a couple of review, and those exit tickets you can review the next morning. If they're quick to sort of give you feedback, you can ask a couple of quick questions. They could be multiple choice, they could be short open-ended, so something that you can sort of look at and get a sense for very quickly, and then review the next day, because you want to be able to tailor your learning. Formative assessments give students a sense for what the learning goals are. And that is important, even in project based learning. It's easy for students to not know what it is that I'm trying to learn at the end of this. And giving those formative assessments sort of give them a sense, this is what I'm supposed to be understanding and learning. And no, I haven't got this. So I need to understand this better so that I can answer this kind of question or whatever. It's also normative, right? Assessment is a normative enterprise. You measure what you treasure, as they say, or what you value. And so if you also value creativity, you also value collaboration, you value these, what we might call socio-emotional, or how is this connecting to your interests. So you want to be probing all of that, because when you probe students with those kinds of questions, they understand what it is that they need to be learning, whether it's communication, whether it's the vocabulary, whether it's collaboration, whether it's the actual concepts of programming, whether it's about their interest being valued. So I think all of that comes through not just the learning goals, but through measurement as well.
Yeah, I love that, the idea of you're basically measuring what you value, but I'm curious, how do you help educators kind of understand what they're communicating as what they value unintentionally, and like thinking through, oh well, I only value like the concepts, like the computer science concepts, like conditionals and variables, etc., etc., and yet I'm not putting a value on creativity and problem solving and like other ways of being that I actually do value, but I'm not actually assessing. So how do you get teachers to understand that what they're measuring kind of displays what they're valuing in the classroom?
I mean, I think good examples play a big role. I think having rubrics for the projects that not just talk about, oh, you have to use a conditional and you have to use a loop, but, assigning or apportioning value to use of media effects, self created media. How have you been creative? What have you done to sort of give students, even in closed ended projects this can happen, and that is something that I have tried all along. Even when you are targeting certain goals, in the project that you have given them. It's a closed-ended project. Make this, make this sprite do this. But if you always make room for the students to bring something of their own into it,
Yeah.
be it the kind of sprite they use, be it the context that you can say make something, but connect it to something that is in your community or whatever. You can find ways. You have to push yourself, and I think it comes back to your learning goals and what the teachers are sort of outlining as learning goals. Our learning goals, and I think the CS framework and other things have done a good job of trying to say that CS is not just about learning the concepts. It is about building mindsets. It's about, I mean, the whole CS for all idea also is about broadening participation in computing, which means we have to attend to interests and race and community and gender and what interests different kids. And student choice in the projects, of course, is always a great way to sort of make sure you bring the student's voice in and make the idea relevant, make the learning relevant to them. But you can't do open choice projects all the time. And so when it comes to closed ended projects, you make sure that you bring in those elements in your rubric. And there has to be something on collaboration, for example. How did you help your partner? How did your partner help you? A simple question like that is sending a signal to them, I'm supposed to be working with my partner and I'm supposed to be doing well. So I think keeping all those goals of CS sort of on your mind at all times, but also realizing, and this again goes back to why teaching is, it's difficult. You can't capture everything in every assessment. And that's one of the things that I speak about in the systems of assessment idea. Some assessments help you with understanding the conceptual stuff. When they're doing a quiz on the conceptual, they know that there's no creativity there per se. There's no, if they're doing it alone, there's no collaboration per se. But there you're foregrounding the idea that concepts are important. But then there is other kinds of assessment that are valuing those other things. And so, taken as a whole, the students leave with an experience that all these things are important. I think it's important to understand you can't get at everything in every kind of assessment, and different forms of assessment are good for different things. It's an evolution. I mean, teachers who have come into CS in recent years obviously had more pressing issues of how do I deliver this curriculum in the classroom. But now it feels like it is time to make assessment conversations more central and more a part of the learning process, to make assessment, how to make assessment a part of the learning process, not to grade, not to, sort of use it for, high stakes and accountability, but really as a means to convey to students what the curriculum is about, what you're valuing, but also getting ongoing feedback on how you're doing on all the learning goals. And it's a multifaceted learning goal for CS for sure.
So what about the CS educators who are really into like puzzle-based forms of learning? So the assessment is basically the puzzle itself is a quiz. There's one right or wrong way to answer it, and there's like no opportunities for creativity within that. How would you get them, or how would you speak to them about expanding beyond that to include multiple forms of not only expression, but assessment?
So again, I think presenting this whole palette of assessments, sharing what various assessments can look like, and to sort of bring home the point that the puzzle-based and the quiz-based assessment, it satisfies one goal, it's one kind of assessment, but you're losing out through that assessment. And what you're gaining through that assessment is perhaps this is the feedback you're getting from that, but you're not getting feedback, or you're not valuing these other things that you value in this curriculum. So you have to sort of mix it up. Today you give a puzzle based assessment, make sure that at the end of 2 days kids are doing some form of a project and giving you feedback through another form. And there you could be making sure that they're able to convey, they're able to bring the creativity and collaboration to the table and other things. And so I think giving a sense for the palette and the plethora of forms of assessment and what each one gives to you, and to make sure that it's not a monocultural diet. You can't just be eating corn all day. You've got to mix it up, because each thing, it's a multifaceted goal and a multifaceted learning process, and therefore a multifaceted set of assessments.
If somebody was in the elevator with you and they're like, "Hey, I heard you released a new book. What is it?" What would your elevator pitch be for the book?
If you are a teacher or a curriculum designer who plans to teach or is teaching coding or computer science as part of CS, or a technology subject or another disciplinary subject, coding can play a role in several contexts. You cannot do without this book. It gives you a sense, for not just a sense, but an understanding of all foundational ideas of introductory programming for K-12. So that includes key concepts, key practices, and key pedagogies. And the book has been created by galaxy of people who have been deeply committed to K-12 CS education in elementary, middle, and high school. It brings together researchers who have researched this topic or who are well aware of the research. And so it brings together classroom practice and learning from, research in the learning sciences and CS Ed. It's really unique in that sense. Of course, the A-to-Z organization is unique. Each chapter starts with a letter of the alphabet. I had to be creative when it came to X, Y, and Z. Yeah, it sort of sets you up with that foundation. So it's not a curriculum, this is where you start and this is where you end. A lot of curricular PD training do go through something like that. But what you leave out through those short training periods are some of these foundational ideas. What is this idea? How are you supposed to, what is the learning there that a child is supposed to come away with? How might you get there, with examples? So there's examples from blog-based and text-based programming languages. In fact, there's one chapter on integration, and I've gone beyond the elevator pitch, okay? So the elevator pitch is just that first sentence. Now describing the book to you. It also includes examples of integration of music by by Jared O'Leary. The idea of the work you've done with assessments also are featured. So we've tried to capture the state of the art, where we're at with our understanding of teaching of CS and programming. And so I think it's a pretty unique book in that sense, because it brings both concepts and pedagogy. It's not focused on one language or one curriculum. It's about the broader fundamental ideas. So a teacher who has not had a background in computing, this book is essential.
What are some of the main ideas that you hope CS educators learn when reading through the different chapters?
At a very basic level, I think they will come away with the understanding that there are foundational ideas of programming. It transcends programming language. And so, very often, an early understanding for many teachers is, I'm teaching Scratch. It's a Scratch curriculum. I'm teaching how to move a block from here to here. This block does this block does this. When you snap them together, this happens. It's not about teaching. The programming language is a tool. The ideas are more fundamental. The programming language sort of brings that idea to life in different ways. I mean, different programming languages use different syntax, but the idea is the same. These foundational ideas of whether it's repetition or conditionals or events or algorithms. And so these are sort of the conceptual ideas. But then there are some practices of computing which we don't normally teach specifically, which are very crucial. Planning and writing, planning your program is essential. Learning to debug your program is essential. How to decompose and, think about modularization, that's an important skill as well. And so those are practices. And then there are all these pedagogies. I mean, there's 35 years of research that have looked at how can we teach these ideas in ways that students will learn them well. And so, the learning sciences brought some ideas to the table. CS education researchers have been doing a bunch of research over the last 30 years. What are the learnings from that? Things like learning to read, reading and writing and tracing programs and how to scaffold the learning, how you can use project-based learning and constructionist ideas, and how learner centered and culturally relevant pedagogy is important. That's one chapter that I'm really happy and glad because it sort of meets this moment as well that we are in right now. And unplugged activities, how do those play a role? And there are some overarching umbrella chapters, like a broad chapter on students conceptions and where they trip up, because we have a good sense and a large body of literature on that. So there's a chapter that's dedicated to that. There's one chapter that's dedicated to the learning goals of teaching CS and programming. And that's a lot of what we've just talked about in our previous segment about mindsets and identity and thinking skills. It's not just about learning those concepts and practices, but it's about all these other things as well. And so, how might pedagogies for inclusivity work? And there's a chapter on programming languages. And that, again, these programming languages might be obsolete a few years from now, but what might be some dimensions of languages? What might you look at? So, David Weintraub and I authored that chapter on what are characteristics of languages that you might consider when you choose a programming language to teach with, introductory CS. And there's a chapter on integration of coding into other subjects. And that, again, is, I think, a very valuable chapter for teachers of science and mathematics and social studies and music and language arts, because we've got examples from all of those and some very rich examples from the field.
So I don't know about for you, but every writing project that I've worked on, whether I'm one of the authors or a reviewer or an editor or whatever, I've always learned something from it. So I'm wondering, what have you learned as a result of editing this handbook on like a wide range of topics?
So I actually started this project with thinking that I would be writing it myself. And I had outlined the book and the chapters and the idea, the core idea of the A to Z and, all the chapter headings. At some point came about through my own thinking, but also through conversations with others. And I ended up making it an edited collection and reaching out to specific people for specific chapters who I felt would sort of better than me at that topic, And I think what I've learned is that, the field is bigger than any one voice. I think a field is sustained through the voices and perspectives of many. Collaboration rocks. So I think the book is just so much the better and richer for having these multiple voices and perspectives from classrooms, K-12 classrooms, college and university, from research, from teaching, from the US, from other countries. So I think that was a big learning.
Looking more broadly, I'm curious, what do you wish that more administrators and educators understood about CS education in particular?
I think there are several aspects of CS. I think we just spoke about this idea of foundational learnings, not just a programming language or something like that. I think they have to understand teacher preparation better. They have to understand measurement better. I do hope they don't try to make this into some sort of a high stakes thing, but understand that this is a skill and learning that should be included in the K-12 curriculum. But it's important that we get it right. And given the nature of the field and computing as an industry, I think we have to attend to issues of equity and diversity and inclusivity in ways that are meaningful, not just checkbox items, which means preparing teachers, preparing all teachers, preparing teachers of color, and knowing how much representation matters to students, to children, to do right by every child. I think we need to think better about differentiation in terms of making sure students who have had prior coding experience don't just learn better, but every student is able to sort of excel and do well in this space. I'm now connecting it to the idea of equity and some of these other issues that have been top of mind for so many of us in recent days. You can't dumb things down for for some students and let some students, do well. So how does the issue of rigor sort of play a role even as we make our curricula culturally relevant and culturally responsive? We need to reach all students in a meaningful way. I think that is terribly important. And, we have to move the needle. If all that comes out of this whole thing is maintaining the status quo, then we would have probably done more harm than good. Because we will have said that this was supposed to be CS for all, and look what it ended up being. I know this wasn't a direct answer to your question about educators, and I think everybody needs to embody cultural competence in computing. That's a phrase and a curriculum and a philosophy, I think. In some sense, Nikki Washington's paper at SIGSI has, been talked about in social media and the SIGSI members group, etc. She's talked about it at the undergraduate level. I think it has to be embodied from the very beginning in K-12 as well. And cultural competence in computing has to play out in classrooms, in teacher PD, and the curriculum. It has to be part of all of it. It's a unique field, I feel, computer science, because it has a very direct linkage to industry and tech jobs in ways that some of the other subjects don't. You don't have a math industry that's only doing mathematics related things. It's an applied field. Computing is playing a role in every aspect, in every discipline, in every field. And I feel we need to do a better job with connecting what comes beyond school, college, and career. We need to do a better job of making those connections, not so much that students go into those jobs and, fulfill this whole workforce, but it is about the learning and the motivation and the identity and the representation. And we really do reach all when we say CS for all.
Yeah, and to add one more category to the college and career, even just leisure. So, like, some of the ways that I've engaged with computer science was just for fun, like modding a video game or things like that.
Absolutely. Historically, when we think about these things, and again, this is not about you per se, but what kinds of students have had the luxury of having coding as a hobby?
Right.
And it's a matter of access. It's a matter of giving all children access to this.
Yep.
Like I said, even I was in the informal space initially. I did feel that bringing it into the formal space would be a better way of leveling the playing field. Although a lot of good work has been done, is being done in the informal space as well.
Mm-hmm.
Initially, in fact, CS for K-12 students was all in the informal realm. And, whether it was the computer clubhouses or, various nonprofit organizations, Girls Who Code, Black Girls Code, they all operate at Technovation. They operate in the informal space, and I think they're doing a great job. But then when you're in the informal space, how do you reach everybody?
Right.
And that is what made me sort of respect the formal learning space as an avenue for CS.
Yeah, one of our core principles that we hang on to at the nonprofit I work for is that we focus on the formal learning spaces because of the access issues. Like, some kids don't have the luxury of being able to do after school programs and whatnot. So we want to be in the school, in the classroom. So we only work with districts who are committed to doing that.
I mean, we have to really do things in a way that move the needle. I mean, I remember when we would talk about the CS for all stuff, when CS for all became sort of a hashtag and a mantra, said, that CS for all is a civil rights issue. But I believe even that needs a rethink. It should be a conditional. If we believe that CS is indeed for all and is a civil rights issue, then CS in K-12 has to be taught and addressed very differently than we have thus far.
Yeah.
We have to transform the system.
Yep.
That's a lot of hard work. If just bringing it into classrooms is difficult, imagine how difficult it is to sort of try to make the tech industry and colleges rethink how we teach computing, but it has to be done.
So, knowing your background and like all the things you've done, it's very difficult, like, especially as a researcher with all the pressures that are put on you and whatnot. And knowing that you are striving for these changes, not just with the teachers you work with, but with systems, how do you kind of prevent the burnout that can be inherent with the kind of high demands and pressures?
Everybody in CS education is just so busy all the time. Everybody is, I think we will all look back on this and hopefully with cheer and a smile rather than, a grimace and remorse. It can be very taxing. I mean, nurture hobbies. I love to do crochet and knitting and gardening. Those are very Zen kind of activities for me. And somehow over the recent years, I've actually picked it up a little more, and it may be my body and mind crying for, a break away from social media and CS ed work and the writing and reading. And it's 24/7, unless you consciously switch off, there is no switching off. So there's that. Having things to do outside of this, I think, is very nurturing. I also feel like, in my own experience, the way I have, it wasn't terribly conscious, but I think I have sought out new collaborations. And with every new collaboration, you're learning different things, you're working with different people, you are expanding your horizons and perspectives, and learning about the same topic but different aspects related to CS education. And I find that that has been very enriching for me, is collaborating with teachers more and more. I have done that more and more. I'm doing that more and more. Co-design, so that the classroom, making sure that teachers have a seat at the table at all times, even when we are doing research, but just all kinds of collaborations, with different folks from different universities. I think that helps. You're not you don't feel like you're in a rut. The new ideas give you new life and new energy and new enthusiasm.
Yeah, it's interesting how like collaborations can simultaneously help prevent the burnout, but also kind of iterate on your own understandings and like teach you new things that you hadn't necessarily considered before.
Absolutely. I think you hit the nail on the head, because these ideas are not, just perspectives help you iterate on your own learnings and abilities. And as an educator, you read others' research, you collaborate, all of that.
And speaking of research, what do you wish there was more research on? Or what do you wish more people had read in terms of some of your own research?
I think we haven't yet really sunk our teeth properly into computational thinking.
Yeah.
I think it comes to life in integration with other subjects, because that is one opportunity to sort of focus more on different representations and abstraction, which is, I think, one of the most core ideas about teaching CT. And it sort of centers the idea of representation and abstraction when we are teaching it in another subject. But I don't think we have sort of really grokked how to do this integration well, how to prepare teachers to do it. I don't think we can succeed in integration unless we have found ways to prepare teachers to integrate coding and CT. And we haven't really done the bridging work really well. This idea of transfer, it's been used as a straw man argument sometimes. Oh, CT doesn't transfer, so CT doesn't exist, or CT isn't a thing. I don't think we have studied transfer well at all yet. I think there needs to be conscious and deep and specific studies around transfer before we can say that transfer doesn't happen, because those of us that have tried it in small ways and different ways have found that it happens. I think we need to sort of understand, this idea of mediating transfer. How do we mediate transfer? How do we bridge to the new context in order to be able to transfer? I mean, we've learned from the learning sciences that transfer doesn't just happen. It doesn't happen for free. It doesn't just come about. You have to work at it in the original context. You have to teach in a way to mediate. And then in the new context, you have to bridge to the old context. Otherwise, the connections, I mean, the way the brain works and learning happens, those connections are not made. So, and I think CT as a disciplinary skill in CS classrooms, this again goes to this idea of not just teaching Scratch or the mechanics of a programming language, but to teach those deeper ideas and those thinking skills. I think it is still a very valuable concept and an idea, and that still needs some work. And I feel happy that a lot of teachers do refer to systems of assessment and have sort of heard about the idea, and or teacher trainers. And I don't think researchers, I wish that were read and appreciated better. The ideas of expansive framing and BFL, the work that I had done around that, I think those are, again, very valuable ideas. The pedagogy of programming. Some recent work that I've done around, how now non-programming activities sort of can be a lead in And it isn't just unplugged. They can be digital. We created digital micro worlds, etc. But all of them get at the fundamental ideas stripped away from the clothing that the programming language brings. And I feel like students need to see those ideas in those contexts so that they can get at them more deeply. If they're always in the context of programming, then sometimes it's hard to separate and hard to help them see the deeper idea separate from the coding. And I think computational thinking coding is a great vehicle, but sometimes you can teach coding and not teach any CT. I think those are some of the things that I still feel, even though I've spent a fair amount of time on that, I still think that there's a fair amount that needs to be done. We haven't written the last chapter on all of that as yet, and we still don't know so much about how to teach it. And there's new ideas every day. Just yesterday, last evening, last night, in fact, on Twitter, Sriram wrote about data science as, the way we should be introducing CS and how, and he's been talking about connecting it to CT. And I have had these ideas for, I think representation and data structures, those are ideas that really have not been thought about very deeply in the context of CT. I'd authored an article called Helping Students See Harry Potter and Hamlet in a New Light with Computational Thinking. And it was fundamentally about this idea of representation and data structures and how organizing information in a way that helps you see, and it's a computational lens. It helps you do computational analyses on it, but you can do it manually too. The idea can be presented manually, but then you can take it, of course, to a whole different level if you do that analysis computationally. But the fundamental idea of creating a data structure like a graph with nodes and edges to represent a novel or a work of writing, to analyze it in a different way, it yields a whole different set of ahas. I'm really fascinated by these ideas of computational journalism using Python scripts to scrape, prison data to do analyses in social studies. It all comes down to representations and thinking about how you represent data and how you analyze that data. Then it can be done computationally. But the fundamental idea of being able to use these representations and transformations is a foundational idea that I don't think we have exploited enough. We haven't studied enough.
Yeah. I think there's, in the very near future, there's going to be a lot more crossover between data analysis and corpus linguistic approaches.
Yeah.
My dissertation looked at like 11 million words of data, found patterns in the discourse, and then like analyzed those patterns in terms of what does this mean for like music related practices and whatnot. And I think more people are going to start looking at like data in those ways from a computational thinking perspective and kind of like combine the CS side of things with the corpus linguistic side of things to just better understand larger patterns in the world that we can't see.
Yeah. Oh, that's so fascinating. Exactly. That's exactly what I have. It's about, and we talk about pattern recognition. We talk about data and representation as CT. And coding is the tool. Coding is certainly a tool there, but the idea is deeper. It's about analysis and pattern recognition and representation, and then coding is your tool that helps you do that analysis.
Yeah, and one of your earlier comments about like university professors and just like CS education researchers like reading more and learning more about assessment. One of the interesting things that I've noticed is there's this weird disconnect between higher education pedagogies and K-12 pedagogies in the CS world, but I don't see that in the music education world. Like there are a lot of music education professors who are like, oh, well, this pedagogical approach works really well in like the high school settings, so I'm going to model it in like even some of the graduate courses and whatnot. But in CS, like what's weird is like there's a lot of university professors that are like, well, I'm teaching undergrads, so therefore I have to approach it entirely different than I would if it was in the K-12 realm. And while on one hand, like, yeah, it's different context, different understandings, etc. But on the other hand, like it doesn't need to be a night and day difference. We don't have to ignore all of the K-12 research just to only focus on the university stuff.
No, that's so true. That is so true. In fact, I mean, there are people that have been fighting for active learning in
Yeah.
in higher ed in CS, but it is a very hard sell, and I guess it's just again these mindsets and systemic barriers and that need to be dealt with. It is very true. I think arts education as well. And the thing is that pedagogy is often studied only at the K-12 level for a lot of things. And then they do stop studying it at the higher ed level. And that is just so unfortunate.
Well, and the fact that like active learning is still like a conversation to be had at the CS education, higher education stuff, like that is not a conversation in like the arts stuff. It's just it's assumed you're going to do active learning, and if you're not, then people will question it.
I think there is this, what some consider a dichotomy, but it isn't. It's sort of a spectrum of, pedagogy and constructionist versus, scaffolded. It's not even an either or. It is about structuring your curriculum in a way that sort of uses the right pedagogy at the right moments. And we've all sort of come very far from thinking that just leaving kids to learn program, every kid will have learned and excelled and will have done got all the things that you want them to learn. We know that that doesn't happen. There are people that come from a very strong constructionist tradition that are paying attention to how to balance the conceptual learning, how to bring in assessment, how to bring it in different ways, but you have to attend to it. Folks like Yasmin and Debbie Fields doing the e-textiles curriculum. Active learning doesn't mean that you're not going to teach them anymore.
Yeah, that's something that I've had to reiterate when I taught music education courses at the university level because they were so bought into the idea of constructivist or constructionist approaches that they thought that like direct instruction was the boogeyman that you had to avoid. And it's like, well, no, it's not a matter of like completely avoiding it. It's just finding ways to use it when it's appropriate and not over relying on it.
Absolutely. Of course, there's a lot of research on what should come first, whether you should precede exploration with explanation. And there's been some studies that have been. The thing about learning is that there is no one size fits all for every context. But when you're aware of these, that sequencing matters. So maybe this time I'm going to try to let them explore a little bit. Maybe it's guided exploration. And then we will talk about it and discuss it, and I will introduce the idea or whatever. Or you can say, I'm going to give them just a little bit of this, and now I'm going to let them go and dig deeper, explore with this initial sort of understanding or whatever. Dan Schwartz and John Bransford had this great paper called A Time for Telling. And of course, in their case, they were showing how students that did more exploration, initially guided exploration, learned better when the explanation was offered than the ones that were first given the explanation and then told to explore. It's a matter of higher ed folks being aware of all of this and aware of all of this pedagogy. It's as if it doesn't apply to them. How to teach only applies to K-12, doesn't apply to higher ed. It's bizarre when you think about it.
Right. And one of the other advices that I give for anybody going into any subject within education is read outside of your field. And so there's like this like silo of like, oh, well, I can only look at education if it's CS education research. And it's like, well, no, like look at physical education, look at the arts, look at social studies, like find other ways that they're doing things and try and incorporate it and learn from it.
I think that is so important. And I feel that that is why this is not a plug or a, rara banner for the learning sciences. But, we read as part of our learning sciences training, we read so much of the research done in learning in general. But learning in general is always set in some context or another, right? Paper that you're reading, it may have been in an informal or a formal context. It could have been a mathematics learning or a science learning. You're always learning about something. Then we come into CS Ed research, and you sort of, have this multiple perspectives of different things that have worked in different contexts. And, not everything is applicable, but you sort of are able to bring that. I find that in CS Ed research, and perhaps this is true of folks that just stay within a discipline always, is that they lack that broader perspective.
Yeah, I agree. I was initially, when I first started going into CS education, just afraid that like I would be lacking the background and the context and whatnot, but I feel like because I came from such a different perspective, I'm able to kind of look at it from a new lens that other people aren't thinking of, and it's sometimes an advantage.
Oh, absolutely. I can completely see that. It's an advantage. You're basically bringing new perspectives and innovations to the fields.
Are there any questions that I haven't asked that you want to talk about?
There is, among some naysayers of CT, they've actually changed the narrative and in a way around CT that I feel is very harmful by saying I don't know if you've heard this, that kids get CT and the rich kids get coding. And I've never really understood that. I would argue that it's actually exactly the opposite. When children are developing deeper conceptual and thinking skills, they're essentially developing those conceptual understandings that takes them beyond the rote mechanics and syntax of coding, etc. They're learning about abstraction and representation. That's, like I've said, it's a foundation of so much analytical thinking that can help them in so many other ways. And also, you read articles. I'd spoken about this at the ICLS in London 2 years ago in a panel about equity and CS. And, you read articles about coding being the next blue collar skill, for example, or that AI is going to write much of the code that's being written today. So then what are we preparing our kids for if all we teach them is coding and not the thinking skills? Like I said, you can teach CT through coding, provided you pay attention to it. And there are many instances where you're teaching it in a way that they're not getting those more valuable analytical thinking skills. And so I think there is, there is an equity issue in here. And I think the equity issue is to attend to the deeper thinking and problem solving skills, even as you teach coding, so that tomorrow, if coding is a skill that's being done by AI and robots or whatever, you are still well positioned, do the jobs that go beyond that. I find that argument a little problematic, and I feel that it is an equity issue to teach kids not just a programming language, part of coding or whatever, but to make sure that you teach those deeper ideas that they can then, whether it's problem solving or abstraction and representation, which helps you when you're thinking about mathematics, when you're thinking in science, even when you're thinking in language arts and other subjects, STEM or non-STEM.
Yeah, whether I'm working with like people with music technology or in computer science or whatever, anything tech related, because it's constantly changing so fast, what I try and encourage people to approach it is, don't think of this as I need to learn this thing right now. It's more of I need to learn how to learn this thing right now, because a month from now is going to be something new that you need to learn, whether it's music related or CS related. Like it's those thinking processes about how to learn that's the important thing in the long run.
Yes.
So where might people go to connect with you and the organizations you work with?
I am at shuchigrover.com. I'm on LinkedIn. I am also on Twitter as ShuchiG. All of that is actually on shuchigrover.com. My Twitter, my email. I just started the website a couple years ago. It sometimes stays dormant, but I have pages on the new book there, on the A-To-Z Handbook, which links to the table of contents and a look inside. So that's a good one-stop place to go if you want to connect with me.
And with that, that concludes this week's episode of the CSK8 podcast. I hope you enjoyed this interview. It was wonderful getting to catch up with Shuchi and hearing her insights on computer science education. If you found the content in this episode valuable, please consider sharing it with somebody else. And stay tuned next week, where we will do an Unpacking Scholarship episode, and then 2 weeks from now, which will be another interview. Thank you so much for listening. I hope you all have a wonderful week and are staying safe.